रयत शिक्षण संस्था सातारा रोज project 2021-22 for 11th science conducted by Yeshwantrao Chauhan Institute of Science, Satara. Now, in the last lecture, we have studied the stock notation. Similarly, we have studied the redox reactions in terms of oxidation number. And the next point that we have studied is the types of redox reactions. That is combination reactions, decomposition reactions, then displacement reactions, and disproportion reactions. These are the types of redox reactions. We have studied these types of redox reactions in the last lecture. Now, in this lecture, we have to study the balancing of redox reactions. The balancing of redox reactions is done by two ways. Firstly, by oxidation number method, and secondly, by ion electron method. By these two methods, the balancing of redox reaction is carried out. Now, let us firstly consider the balancing of redox reaction by oxidation number method. Now, what is oxidation number? We have already studied. Now, by this method, the balancing of the oxidation reduction reaction is carried out. And how it is to be carried out, that we have to study. Now, there are some steps to be followed for the balancing of redox reaction. The given equation is an unbalanced equation, and we have to balance this unbalanced oxidation reduction equation. The first step is write an unbalanced equation for redox reaction. So firstly, the equation we should write on paper. There is unbalanced equation. Then step second, assign oxidation numbers for each atom. So then, after writing the unbalanced equation, the step second is to be followed. That is, we have to write the oxidation numbers for each atom in the reaction. And then identify and write all redox couples in reaction. That is, we have to identify which element has undergone the oxidation and which one has undergone the reduction with the help of the oxidation number methods. Then draw the brackets to connect atoms undergoing change in oxidation number in redox reaction. तिसरी जी सब स्टेप आहे त्यामध्ये जे एलिमेंट्स ऑक्सिडेशन आणि रिडक्शन झालेले आहेत ज्यांचे तिथं ब्रॅकेट करायचं आहे. जे इन्क्रीज इन ऑक्सिडेशन नंबर आणि डिक्रीज इन ऑक्सिडेशन नंबर असे जे एलिमेंट्स आहेत त्या ठिकाणी ब्रॅकेट करायचं. म्हणजे पटकन लक्षात येतं की कोणत्या एलिमेंटचं ऑक्सिडेशन झालं आणि कोणत्या एलिमेंटचं रिडक्शन झालं. So draw the bracket to connect atoms undergoing change in oxidation number. Then show an increase and decrease in oxidation number per atom of oxidized species and reduced species respectively. So with the help of oxidation number methods, we can show the increase and decrease in oxidation number per atom of the oxidized species and reduced species. If there is an increase in oxidation number, the species is oxidized. And if there is a decrease in oxidation number, the species is reduced. That means जर ऑक्सिडेशन नंबर वाढला त्या इलेमेंटचा, रिएक्टंट आणि प्रोडक्ट साइड या दोन्हीचा कन्सिडर केला असता, रिएक्टंट पासून प्रोडक्ट तयार जो होतो तिथं जर त्या इलेमेंटचा ऑक्सिडेशन नंबर वाढला त्याचा अर्थ तो इलेमेंटचा ऑक्सिडेशन झाला. आणि जर त्याचं ऑक्सिडेशन नंबर कमी झाला, डिक्रीज झाला, तर त्या इलेमेंटचं रिडक्शन होतं. Then determine the factor to make total increase and decrease in oxidation number equal. So we have to equalize the total number of oxidation and reduction number. That means by this step we have to equalize the number of electrons lost and number of electrons gained. And then the step third is balance all other atoms except hydrogen. Except hydrogen. Hydrogen सोडून इतर सगळे atoms हे काय करायचे? बॅलन्स करायचे. आणि त्यानंतर balance the oxygen atoms by adding H2O to the side containing less oxygen atoms and hydrogen atoms by adding H plus to the side with less hydrogen atoms. आणि या स्टेप मध्ये हायड्रोजन आणि ऑक्सिजन हे बॅलन्स करायचे. तर कशा पद्धतीने करायचे? बॅलन्स द ऑक्सिजन आयटम्स बाय ऍडिंग H2. जेवढे लेफ्ट साइडला ऑक्सिजन आहेत तेवढे राईट साइडला ऑक्सिजन करण्यासाठी तेवढे H2O मॉलिक्युल्स घ्यायचे. राईट साइडला म्हणजे प्रोडक्ट साइडला, म्हणजे ऑक्सिजन बॅलन्स झाले. आणि हायड्रोजन बॅलन्स करण्यासाठी कंटेनिंग लेस oxygen atoms and hydrogen atoms, they are balanced by adding H plus atoms to the side with less hydrogen atoms. जिथं हायड्रोजन atoms कमी आहेत, ज्या साइडला हायड्रोजन atoms कमी आहेत त्या साइडला H plus ions ऍड करायचे आणि हायड्रोजन बॅलन्स करायचे. या पद्धतीनं by oxidation number method the redox equation is balanced. And the next step is for the reaction in basic medium, add OH equal to the number of hydrogen atoms. जर रिएक्शन बेसिक मीडियम मध्ये असेल तर add OH minus ions equal to the number of hydrogen ions added in above step on both sides of equations. And then hydrogen, that is H plus ion, and OH minus ions on same side of equation are combined to give the H2O. H2O, जेवढे हायड्रोजन आहेत तेवढे ऑक्सिजन, तेवढे H2O molecules same side. So H plus and OH minus on same side of equation are combined to give H2O. म्हणजे जेवढे H plus आहेत आणि OH minus आहेत तेवढे H2O मॉलिक्युल्स त्या साईडला लिहायचे. आणि त्यानंतर शेवटची जी स्टेप आहे ती फायनली चेक द इक्वेशन विथ रिस्पेक्ट टू बोथ नंबर ऑफ ऍटम्स ऑफ इच एलिमेंट अँड द चार्जेस. जी लास्ट स्टेप आहे त्यामध्ये सर्व ऍटम जे लेफ्ट साइडला आहेत म्हणजे रिएक्टंट साइडला आहेत आणि राईट साइडला आहेत म्हणजे प्रोडक्ट साइडला आहेत तेवढे ऍटम जेवढे लेफ्ट साइडला आहेत तेवढेच राईट साइडला आहेत हे चेक करायचं आहे. आणि जेवढे चार्जेस लेफ्ट साइडला आहेत रिएक्टंट साइडला आहेत तेवढेच चार्जेस राईट साइडला आहेत का ते सुद्धा चेक करायचं. And in this way the redox equation can be balanced. Now let us balance this redox equation by oxidation number method. For example, here the example is given. CuO plus NH3 gives Cu plus N2 plus H2O. Now this is an oxidation reduction equation. To the left hand side, to the reactant side NH3, there is a one nitrogen. To the product side, there are two nitrogen atoms. That means the equation is not balanced. So we have to balance this equation. Similarly, there are in NH3 there are three hydrogen, but to the product side there is H2O. There are two hydrogen atoms. So three hydrogen atoms to the left side and two hydrogen atoms to the right side. So this equation is not balanced, and this is to be balanced by using oxidation number method. Now step 1, write the skeletal equation. Balanced elements other than oxygen and hydrogen. That is CuO plus NH3 use Cu plus N2 plus H2. So this is first step that we have written. म्हणजे पहिल्यांदा जे अनबॅलन्स्ड इक्वेशन आहे ते आपण लिहिलेलं आहे. त्यानंतर दुसरी स्टेप काय सांगते? In a second step, assign oxidation number to Cu and N, because the change in oxidation number takes place as far as copper and nitrogen is considered. So in CuO, the oxidation number of copper is +2. Whereas to the right side, Cu, the oxidation number is 0. The oxidation number of copper is a 0. So +2 changes to 0. And in case of NH3, the oxidation number of nitrogen is -3. Whereas in N2, to the right side, there is a N2. The oxidation number of nitrogen is 0. So -3 changes to 0. Now, increase in oxidation number of nitrogen from -3 to 0 and decrease in oxidation number of copper from +2 to 0. And therefore, equalize net increase and decrease as, that is to be equalized by multiplying by 3 to the CuO and by 2 to NH3. And thus, thrice of CuO plus twice of NH3 gives thrice of Cu plus N2 plus H2O. H2O as it is given in the equation. Now, this step third, जी आताची जी स्टेप आहे सेकंड स्टेप, त्यामध्ये कॉपर बॅलन्स झाले, नायट्रोजन बॅलन्स झाले, परंतु हायड्रोजन आणि ऑक्सिजन बॅलन्स झालेले नाही, तर ते आता बॅलन्स करायचे. सो इन स्टेप थर्ड, balance oxygen atoms by adding H2O to right side. So to the left side there are 3 oxygen atoms. So we must write 3 H2O molecules to the product side. And therefore, twice of CuO plus twice of NH3 gives twice of Cu plus N2 plus twice of H2O. Again, the charges are already balanced. And the step 5, check two sides of balanced equation. So to the left hand side and to the right hand side, the number of atoms, they are balanced, that is to be checked. So to the left hand side there are 3 copper, to the right hand side there are 3 copper, there are 3 oxygen, to the left hand side, to the reactant side there are 3 oxygen atoms, to the right hand side. Similarly, there are 2 nitrogen. Twice of NH3 means there are 2 nitrogen atoms. So to the right hand side there is N2. And hydrogen, to the reactant side there are 6 hydrogen. To the product side again twice of H2 means there are 6 hydrogen. And in this way the equation is balanced. So by this method the redox equation is balanced. This method is known as oxidation number method. Now the second method is ion electron method, or this method is also called as half reaction method. Primary steps for balancing in acidic solution. The steps are, in this method, 2 half equations are balanced separately and then added together to give balanced equation. The steps, there are some which are to be followed to balance this equation. Firstly, write unbalanced equation for redox reaction. Assign oxidation number to all atoms in the reactants and products. Secondly, pick out the elements being oxidized and reduced. म्हणजे जो एलिमेंटचं ऑक्सिडेशन झालेलं आहे आणि ज्याचं रिडक्शन झालेलं आहे ते डिटेक्ट करायचे. अँड राईट आउट देअर अनबॅलन्स्ड हाफ रिएक्शन्स सेपरेटली. त्यांच्या अनबॅलन्स्ड इक्वेशन्स आहेत, अनबॅलन्स्ड हाफ रिएक्शन्स आहेत, ते सेपरेटली लिहायचे. Then the third step, balance the non-oxygen and non-hydrogen atoms. Then balance oxygen atoms by adding H2O molecules to the side with less oxygen atoms, and hydrogen atoms by adding H plus ions to the side with less hydrogen atoms. म्हणजे ऑक्सिजन ॲटम बॅलन्स करायचे H2O मॉलिक्युल्स ऍड करून, आणि हायड्रोजन ॲटम्स हे H प्लस आयन्स ऍड करून बॅलन्स करायचे. Then balance the charges by adding appropriate number of electrons to the right hand side of oxidation half reaction and to left hand side of reduction half reaction. त्यानंतर सिक्स्थ स्टेप जी आहे, मल्टिप्लाय half equations by suitable factors to equalize the number of electrons in two half equations. Add the two half equations, cancel the number of electrons on both sides. जेवढे इलेक्ट्रॉन्स लेफ्ट साइडला आहेत तेवढेच राईट साइडला इलेक्ट्रॉन्स असतात आणि ते कॅन्सल करायचे इलेक्ट्रॉन्स. सो नंबर ऑफ इलेक्ट्रॉन्स लॉस्ट becomes equal to the number of electrons gained. And then for basic medium, add OH equal to H plus ions on both sides of equations, and check the equation. And then lastly, check the equation with respect to number of atoms and the charges. For example, let us consider this equation: MnO4 plus 8 of H plus 5 Fe2 plus gives Mn2 plus 4H2O plus 5 Fe3 plus. हे अनबॅलन्स्ड इक्वेशन आहे आणि हे अनबॅलन्स्ड इक्वेशन आपल्याला आयन इलेक्ट्रॉन मेथडनं बॅलन्स करायचं आहे. In ion electron method, one reaction is divided into two reactions, half reactions, and then they are balanced and then added together. The figure, the reducing, that is increase of electrons, and oxidizing, decrease of electrons agent, that is oxidizing agent. Here Fe, now Fe2 plus, the oxidation number of Fe is a 2 plus. MnO4 plus, the oxidation number of Mn is 7 plus, oxidation number plus H plus, that is equal to Fe3 plus Mn2 plus twice of H2O. So here Fe2 plus changes to Fe3 plus, and thus the iron is being oxidized. And in MnO4, the plus 7 changes to 2 plus. In the ion MnO4, Mn has a charge, MnO4 plus ion, the charge is plus 7, and it changing into 2 plus in this reaction, and therefore thus the MnO4 plus is being oxidized. Now balance the oxygen atoms. MnO4 plus is equal to Mn2 plus 4 oxygen. Now you can see in the reaction that oxygen is used to make water, and no oxygen is left, which is O2. and thus 4 oxygen atoms can produce 4 water molecules. So MnO4 plus H plus gives Mn2 plus H2 plus 4 of H2. So balance the equation, this reaction, that is MnO4 plus 8 of H plus gives Mn2 plus 4 of H2. Now for a redox reaction, the addition of charges on both sides should be equal so that the charges are to be balanced. Now it is -1 charge plus 8, that gives +7, and +2 charge plus 0 gives +2. And therefore MnO4 plus 8 of H plus 5 electrons is equal to Mn2 plus 4 H2O, where 5 electrons is they are added, and hence the Mn plus 7 charge changes to Mn2 plus. Now Fe2 plus is equal to Fe3 plus. So one electron is lost in this reaction, and therefore Fe2 plus is equal to Fe3 plus an electron. Now we want 5 electrons, not 1. So to get 5 electrons, you must have more Fe2 plus, and therefore 5 of Fe2 plus gives 5 Fe3 plus 5 electrons. Now add both the reactions. MnO4 plus 8 of H plus 5 electrons plus 5 Fe2 plus gives Mn2 plus 4 H2O plus 5 Fe3 plus 5 electrons. Now let us cancel these same terms. So 5 electrons, they get cancelled. And the net equation becomes MnO4 plus 8 of H plus 5 Fe2 plus gives Mn2 plus 4 H2O plus 5 Fe3 plus. And thus the net equation becomes 5 Fe2 plus aqueous plus 8 of H plus aqueous plus MnO4 aqueous gives Mn2 plus aqueous plus 4H2 liquid plus 5 Fe3 plus aqueous. So this equation is a balanced equation. So let us check this equation. To the left hand side there are 5 Fe. To the right hand side again there are 5 Fe. Similarly, to the left hand side there are 8 hydrogen. To the right hand side there are 4 H2. So hydrogen is also balanced. To the left hand side there is MnO4, 1 Mn. To the right hand side again there is a 1 Mn. So all the atoms, they are balanced. In this way, by ion electron method, the redox equation is balanced. Now next point is to study the redox reaction and electrode potential. To study this redox reaction and electrode potential, let us consider the Daniell cell. Many of these things in life are related either directly or indirectly to the electrochemical reactions. The Daniell cell is an electrochemical cell named after John Frederick Daniell, the British chemist who invented it in 1836. A galvanic or voltaic cell is a device in which electricity is generated by redox reaction. For example, Daniell cell. The displacement reaction represents redox reaction. In this cell, Zn solid plus Cu2 plus aqueous gives Zn2 plus Cu. In the above reaction, Zn gets oxidized to Zn2 plus and Cu get reduced to metallic Cu. This reaction can be carried out by using Daniell cell. So here a Daniell cell is represented by a diagram. To the left hand side, there is a zinc electrode which is dipped into the solution containing Zn2 plus ions. And to the right hand side, copper electrode is dipped into the solution containing copper 2 plus ions. For example, copper sulfate. So zinc is dipped into the zinc sulfate solution and copper electrode is dipped into the copper sulfate solution. The two electrodes, they are connected by external wire, and the two solutions, they are connected by a salt bridge. Now the construction is shown here. A salt bridge connects two half cells as shown in figure. A circuit has two parts, one in the form of metallic wire allowing flow of electrons, and other solution part where the electric current is carried out by movement of ions. How this Daniell cell works, that we have to consider. Zinc atoms on plate lose electrons to form Zn2 plus ions, and these electrons, they flow from Zn plate to copper plate, where electrons are gained by copper 2 plus in copper sulfate solution and get reduced. Zinc plate acts as an oxidation electrode, that is anode, whereas copper plate acts as a reduction electrode, that is a cathode. So as a result of oxidation and reduction reactions, there is a flow of electric current in external circuit from anode to cathode, indicated by deflection of voltmeter, and conventional current from cathode to anode. So here oxidation half reaction is shown as well as reduction half reaction is shown. That is Zn gives Zn2 plus 2 electrons. That is oxidation half reaction. And reduction half reaction is Cu2 plus 2 electrons gives Cu. Now, an electric potential established at the two electrodes of cell is called as electrode potential. The two chemical species, they are linked by transfer of electrons from a redox couple. Okay. Now, the standard electrode potential. What is standard electrode potential? It is represented by E0. It is the observed electrode potential when concentration of each species taking part in an electrode reaction is unity and the temperature is 298 Kelvin. The standard hydrogen electrode is used as a reference electrode. The potential of standard hydrogen electrode is 0 volt for determination of standard potential values of various redox couples. Now, for the significance of E standard value, the significance is that the value and the sign of E standard is a measure of the tendency of active species in the electrode reaction to remain oxidized or reduced form. A negative E standard value means redox couple is a stronger reducing agent than the hydrogen, that is a hydrogen couple, and lower negative value of E standard, E0, that is stronger reducing agent, and more positive value of E standard is a stronger oxidizing agent. So here the series is given of different elements according to to their standard electrode potentials. This series, it is known as EMF series or electromotive force series, or it is also called as electrochemical series. Okay, here this chapter is completed. Okay, bye.